We're wondering what the function tangent of x minus pi over 2 looks like when compared with the function tangent of x. Now, it's a little ambiguous the way you wrote it, so we don't know if it's tangent of x minus pi over 2, like this, or if it's tangent of x minus pi over 2, like this, and I'll show you the difference of both of those. So I have here the basic parent function for tangent, and it's actually a parent function for any function. We have all the same things happening. The first thing we look at is this number out here. This is a vertical stretch. You see how it's outside the function? It's outside this tangent function. That means it's going to change your y values. So it's going to change your y values. It's going to make them bigger or it's going to make them smaller. Do you see how this d is also outside the y values? See how it's not doing what the tangent is doing? All of these things are inside the function. This is outside the function. And since it's outside the function, it's also going to change your y values. But what it's going to do is it's going to add or subtract to them. So basically it takes your whole function and it shifts it up or it shifts it down. Okay. So these two are going to affect your y values because they're outside the function. These two are going to affect your x values, the b and the c. They're going to affect your x values because they're inside the function, because they're inside with the x. Okay. Now, that's why this is so important, whether this looks like the first one or the second one. If it looks like the second one, see that pi over 2 is inside the function, so it's going to change your x values. And if it looks like the first one, it looks like it's outside the function, which means it's going to change your y values. So if something is inside the function with the x, this b value here is going to divide all your x values by b. That's called a horizontal stretch or compression. And the c value is going to add or subtract those from to your x values. And now what I like to say is that your x is a liar. So if x says it's going to subtract a number, it's really going to add it. So when you think, oh, I'm going to subtract 2, you would think you're going to go left 2 with your function, but that's not what the case because your x is a liar. So you're going to go right 2. Okay. So if the function looks like this bottom function here, what this is going to be, since this is inside the function, that's going to be a horizontal shift. And it's going to be a horizontal shift to the right because it has a minus sign, and minus sign means usually to the left, but since your x is a liar, we're going to go the opposite way. So that's going to be, oh, I hate it. My pen sometimes does that and then I can't get rid of it. Oh, look at that. Okay, there we go. Horizontal shift left pi over 2, which means you're going to take all of your points and you're going to move them pi over 2. I have a feeling that's what the question was asking, because we typically shift left and right pi by pi values because that's what our x axis is labeled as. So that's what this one would be. Now, if it happens to be the other one, this one would be a vertical shift because it's outside the function. So this is a vertical shift. And this would move it up or down. And your x is a liar, but y doesn't lie. Okay, so since this is changing your y values, it's just going to go down pi over 2 because negative means down. And since y doesn't lie, it's just going to go down. So since outside the function, it's going to change your y values. Inside the function, it's going to change your x values.